All right. So here we see this side's 3, this side's 5, and we have parallel lines here. So if we have parallel lines, what do you think about LM and NMN compared to the 3 and the 5? Should they be the same lengths as 3 and 5? Do you think they have to be the same lengths? No. Do you think they should be proportional to 3 and 5? And the answer is yes. Okay? So they say if this whole side is 9.6 from here all the way down to here. Okay? If that whole thing is 9.6, obviously this adds up to 8, so they're not the same. This is a little longer, but we should see if they are proportional, if they're divided up proportionally. Okay? So, if we make this x and the whole thing is 9.6, what's left for mn? What do you think is left for mn if we use x of it here and the whole thing's 9.6? Well, if the whole thing was 10 and this was 4, what would this be? 6. How'd you get that? By using what? Or subtraction, yeah, right? You subtracted, you took 10 minus 4 equals 6. Well, if this is 9.6 and this is x, what's this? 9.6 minus x. 9.6 minus x. So now we set up a proportion. This over this equals this over this. 3 over 5 equals x over 9.6 minus x. How do you solve a proportion? What's our magic words? We cross multiply. 5x equals 3 times 9.6 minus x. So if we distribute, 5x equals 3 times 9.6 is 18, carry the 1, 28.8 maybe, minus 3x. If we add 3x, 8x equals 28.8. Somebody, calculadora, por favor. 28.8 divided by 8. 3.6. So up here we have 3.6, and the whole thing is 9.6. This would be 6. Okay? So, that's called the side splitter theorem. If we have parallel lines, this side over this side equals this side over this side. Or, another way we can say it is this side over this side equals this side over this side. Either proportion works. Either proportion works. So if you have parallel lines, it splits the sides of a triangle proportionally. Okay? So if this is 4, this is 4, if this is 5, then this has to be 5 because this is split proportionally. Now, what else happens is if this happens to be at the midpoint, where this is 4 and 4 and 5 and 5, this side is going to be half of this side. Okay? That side is going to be half of that side. Now, that's only when it hits at the midpoints. Up here, this one didn't hit at the midpoint, so we couldn't say anything about that. But when we hit at the midpoints, the side splitter will be half the size of the line it's parallel to. The side splitter will be half the size the line is parallel to. Okay, there's a bunch of x's and y's here. Let's figure out what all the x's and y's and z's are. Okay, so first thing I want to figure out is what x is here, I think. So to figure out x, I'm going to redraw this. And yes, this is a bad drawing, but I'm going to draw this here where this is x. What's 9 plus 3? What's 9 plus 3? 12. What's 12 plus 4? 16. And then we have x plus 2. So this over this equals this over this. So 16 over x plus 2 equals 12 over x. What do we do to each side? Cross multiply. 16x equals 12 times x plus 2. 16x equals 12x plus 24. If we subtract 12x, so we get 4x equals 24. So x equals what? 6. X equals 6. So if this is 6, this is 8. Okay? So this is 6. This is 8. What's 8 plus 4? 12. So this part right here is 12. And this part right here is 9. So what do we know about V and U? They are the whats of the sides of the triangle. The, starts with an M, midpoints. So if you have a midpoint that splits, if this is 30, what's Y? 15. There's no way to know Z here. Sorry. We aren't going to know what Z is exactly. Okay. So if BD is 16, CE is 18, BE is 24, find AD. Okay, side splitter theorem. So what over what equals what over what? Jillian, how would we set this up in a proportion? What do we do right up here? What do we do here? I put 3 over 5, x over 9.6 minus x. So what will we do here? So what? Give me the numbers. What over what? Yep, there you go. So cross multiply. 24x equals what's 16 times 18? Somebody with a calculator? Everybody should have their calculators out, please. 288. Then if we divide by 24, what is x? 12. 16 over 12 equals 24 over 18. The corollary to the side splitter theorem is we don't have to have a triangle, okay? But if we have 3 parallel lines, this over this equals this over this. Now, you could also go this over this equals this over this, okay? So, here's an example. A reflecting pool is separated by walkways on a parallel by walkways parallel to Lincoln Street and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? Okay, so we want to know how much tiling there is here. Okay, so to figure out this, okay, these are parallel to each other. Okay, so everything is split proportionally. So Ellie Keller, how would I set up my proportion with just this part of it to figure out X? What over what equals what over what? X over 24, yep. Yep, x over 24 equals 60 over 72. Could have I gone x over 60 equals 24 over 72? Yep, I could have done that way too. Either way is correct. So you're not wrong doing it either way. 72x equals whatever 24 times 60 is. I'm not sure just off the top of my head what that is. I would think it would be 1440. And if we divide by 72, x should be somewhere around 20 feet, correct? Okay, let's figure out what y is. Now that we've done this, let's figure out what y is. How would you figure out the proportion for y, Alex? We could do y over 24, that's just fine, equals. Not quite, because if you went in this direction, you have to keep going in this direction. So it'd be 72 over 60. It makes a big difference whether you go 60 over 72 or 72 over 60. So if you go y over 24, which is just fine, if you go up, then you got to go up with the other one. Cross multiply, 60y equals, I don't know what, 24 times 72, help me out. 1728 divided by 60, and you're going to get a decimal. What is the decimal that we get? 28.8. There we go. Okay, just setting up proportions and solving proportions. Okay, now this is like the side splitter theorem, but it's called the triangle angle bisector theorem. If you have an angle bisector, it splits up the triangle proportionally. This over this equals this over this. Okay? So 14 over 10.5 equals 10 over 7.5. If we cross multiply, 10 times 10.5 is 105. 14 times 7.5 is 105. They check. It works. Okay? So the triangle angle bisector theorem says this, that this, well, they say this over this equals this over this, if you want to go that way. Or you could say this over this equals this over this. Because a triangle angle bisector splits up the third side of a triangle proportionally with the same proportion as the other two sides. Okay? So, if you see that, if this is x and the whole thing is 13, what's left for CD, Julia? How would we write CD as an expression if this part is x and the whole thing is 13? Not x minus 13, but 13 minus x. Okay, we got to go in the order of 13 minus x. Because if this is 13 and this is 3, then 13 minus 3 would be 10. So we would just subtract those, but we have to take the whole distance minus this part. Now we set up a proportion. How do we set up the proportion, Isabel? Well, okay, you can go in the order x over 13 minus x. That is perfectly fine. If we go here to here, then what would the other side of the proportion be? 10 over 16. Okay? You can do it that way. You could do x over 10 equals 13 minus x over 16. Either way is just fine. We cross multiply, 16x equals 130 minus 10x because we have to use the distributive property. If we add 10x to each side, 26x equals 130. If we divide by x, or 26, x equals 5. So this is 5, and this is 8. 8 over 16, 5 over 10, that surely looks proportional. Okay. How would you set up this one, Max Bruns? Here you go. Draw. Hello. Okay. Okay, that's fine. Bye. That work? Office. You can leave your stuff. Does that work? X over 7, he went this way, so then he went 3.5 over 2. That works. You can go 7 over 2 equals x over 3.5. You can go 3.5 over x equals 2 over 7. Okay, as long as you're consistent with the parts that you're putting over each other. So we cross multiply, 2x equals 22, no, 20, 23.5? 24.5. Yeah, I was struggling with that one. Divide by 2, so x equals 12.25. Okay? So today is all about proportions. Okay? Side splitter theorem. This over this equals this over this, or this over this equals this over this. Triangle midsegment theorem. This over this equals this over this, or this over this equals this over this. And if these are midpoints, the midsegment is half the length of the side it's parallel to. And the triangle angle bisector theorem, this over this equals this over this, or this over this equals this over this. Okay, any of those proportions work. So it's all proportions, 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 except for this. If it's a midpoint, then it's half the length of the other side. Okay? So today, what? Question? Or we'll just talk about it later.
Like, are we not doing physical notes like last time, or?
I don't know what you're asking, so we'll just talk in a second. Okay, so what we will do is I will put out an assignment here.